Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 2nd. Looking at significant wave heights for the South Pacific Ocean, we see a very calm pattern. One small patch of 20-foot seas, and that's it. This is historically normal for this time of year. Let's do a quick pass through the southern hemi. Just take a quick look at the forecast charts for the coming week. There is not a whole lot forecast, as you see. A little area, 28-foot seas on Tuesday night in the Southeast Pacific. That might be good for small pulse of maybe 15-second swell for California. And then 30-foot seas are forecast into Wednesday night, but all that's outside the California swell window, good only really for Chile. Another little pulse here right on the hairy edge of the Southern California swell window on Friday morning. 26-foot seas aim northeast, maybe another little pulse, a small swell to result. And after that, things pretty much just go to sleep, as would be expected for this time of year. Let's turn our attention to the North Pacific. We'll start with jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. What we're looking for is a dip in the jet, or a trough. That is a dip, like right there. That would help support a counterclockwise flow aloft and down at the surface. That's the hallmark of low pressure, and low pressure, of course, generates winds. Winds generate seas. Seas generate swell as it radiates away from the fetch area and creates surf when it hits your beach. We have a bit of a trough right now over the dateline. Here's the international dateline. But there's no real wind energy associated. We have a pocket here of, what is that, about 150 knot winds. Another little pocket here of 130 knot winds. Nothing in between. Nothing really supportive of gale development. As we roll into Monday, the trough gets a little bit better defined, but still not particularly great. A little bit of a steep trough here on Monday night, and then it all pinches off. The real interesting part starts Tuesday here when we get pockets of 140 knot winds pushing off of Kamchatka a little bit. See that dip there? Again, counterclockwise. That might help support a gale. And as you move into Wednesday, notice winds build to almost 180 knots. There they go, 180 knots. And that is a much better defined trough, though a bit north and off to the west. North Dateline region is where most of the activity looks like it would probably occur if it were to occur. But then this low, or this jet, gets much better defined here. This is the southern branch. It's not split. Notice just a singular flow pushing across the North Pacific down at about 42 north. Looking pretty well organized and building more into Saturday. Notice the jet makes it almost the whole way across the North Pacific Ocean. What is that, about 160 knot winds in it right there. No real trough organized, but maybe a gentle trough trying to organize come Sunday. That's almost a week out. Hard to believe. And there we are at 180 hours out. But notice the jet is down almost 35 south here over Japan. That would pick up tropical moisture, help feed it into this building trough here in the Western Gulf a week out. Hard to believe any of this, but the pattern does look much more supportive of gale development than it has at any time this year so far. Let's go take a look down at the surface. Here we go, surface level pressure, surface level winds. Notice high pressure, 1028 millibars off the U.S. West Coast. Making a little bit of fetch here, was at 15 to 20 knot fetch pushing into the Hawaiian Islands. Good for easterly wind swell. And a little bit of a low. I mean, this is not a wave-producing, swell-producing low here in the Gulf of Alaska, but low pressure nonetheless. And then a typhoon, Chaba, pushing off to the west-northwest, south, or actually northwest, sorry, south of Japan. Keep your eye on this as we roll through the presentation. So here we go. We're into Monday. Low pressure continuing in the Gulf of Alaska. High pressure off California. Another low up here in the Bering Sea of no consequence. Winds start developing in the low off of British Columbia on Monday night. Little area, 35, maybe 40 knot winds. Falling southeast. This is the pattern we talked about I think it was last week, where with this westward displaced La Nina, the thought is high pressure would reside mainly in this area, and the storm track would fall down the U.S. West Coast. That's exactly what this looks like, at least right now. Backdoor front heading towards maybe Northern California or so. Far more interesting here, low pressure developing on Tuesday off the Pacific, over the northwest Pacific Ocean, 40, almost 50 knot winds there, 45 knot winds. There is a trough in this area forecast, so this is not unexpected. Moving to the dateline into Wednesday night. Also notice what was Chaba that was over here, moving in right behind it. So let's see how, and another little low here also in the Gulf of Alaska. Things looking much more energetic. This system fades out come Thursday. Here comes the Chaba system behind that. It's probably extratropical. Looks like 55 knot winds. That would make it a storm, but quickly moving east, having a hard time getting traction, and then probably getting pushed up into the Bering Sea. Oh, actually not per this model. This is the latest update here. 45 knot winds regenerating in the Gulf, Western Gulf on Saturday into Sunday. That would look very conducive to swell development. So just looking at these charts here, we have at least two significant, I won't call them significant class swells, but two significant low pressure systems, gales, forecast for the Gulf, plus a little thing early in the picture we saw here off the U.S. West Coast. Let's go take a look at the wave height models. And here we go. Really nothing going on other than swell associated with Chaba, supposedly 43-foot seas in this area here. But all this energy is aimed into, let's say, Asia. Nothing back towards the U.S. West Coast or Hawaii. Roll this out. Remember, a little bit of a low pressure here in the Western Gulf come Monday. Generates 20-foot seas, falling southeast, barely in the swell window, mainly from Point Reyes northward. Here comes the first system on 18Z on Tuesday, 30-foot seas, building to, what is that, about 32? No, it says, what is that? No, that's a different system. So we're there at 32, maybe 34-foot seas, making its way towards the dateline, falling to 30 or 31-foot seas, and then petering out. But that's still good for a bit of long-distance swell. Certainly for Hawaii. Hawaii will do better. California, still some swell possible if this plays out as expected. But that roughs up the ocean surface pretty good. So this forecasted extratropical storm Chaba has some good speed bumps, so the fetch from it can get good traction on the ocean surface, generating seas in the 32-foot range. Now notice just over a very small area come Friday into Saturday, but then the system is forecast to move into the Gulf on Saturday with 34-foot seas building to 36-foot, 37-foot, and maybe even a little bit more into Sunday. That looks fairly supportive of large, longer period swell for the U.S. West Coast, sideband energy for Hawaii, but at 168, okay, we'll be a little bit more conservative. At 156 hours out, hardly believable. That's a week away. So basically, this is just something to watch. Undoubtedly, the models will downgrade this as we get closer, but still a nice start, finally, perhaps, for the fall. And real quick, here's a look at Chaba, the track, currently at 115 knot winds. Again, moving to the north-northwest. Forecasted earlier today, it was forecast to go right over the central part of Japan. Now it's forecast a little bit to the north. This would actually be better. That means it wouldn't get all sheared in the mountains here. The shear range would just be right in here. The more over water, the better. Still, when it gets out here, we're talking only 35 knot winds. It'll take the jet stream tapping that, pushing it to the northeast, and then it supposedly is to build again. We'll see. But good to see some recurvature in the storm track. This is pretty typical for late in the season. Next up, let's take a look at long-term projections, specifically the MJO and, of course, La Nina and maybe the PDO. First up, we look for the presence of the MJO, the Madden-Julian Oscillation. Two phases, active phase and inactive phase. The MJO travels from west to east on the equator. This is the West Pacific here, East Pacific, but it travels the whole way around the globe. But relative to the Pacific, 3 to 4 weeks in the active state, 3 to 4 weeks followed in the inactive state. When it's in the inactive state, what you get is exactly what you're seeing here. East winds, especially this area here, we call it the Kelvin wave generation area, from roughly 170 west, almost the dateline, 5 degrees north and south of the equator, to about 135 east. It is this area when you have westerly anomalies in this area, or slack winds actual winds, that tends to help enhance the jet stream, which helps to support storm development in the northern hemisphere in winter months. Clearly, we see right now trades in effect, including in the Kelvin wave generation area, anomalies, differences in normal from this time of year, a normal wind pattern in the greater Pacific, equatorial Pacific. In the Kelvin wave generation area, easterly anomalies. This is a little bit puzzling that we have easterly anomalies, yet supposedly a building storm track in the North Pacific, not out of completely out of normal, even during the inactive phase of the MJO, which it appears we're in given these wind conditions here. You can still have storm development. It's just the likelihood for it is not as high as if you had the active phase of the MJO and westerly anomalies or slack winds here. Here's another chart. This is the whole world on one chart. This is wind anomalies. Purples and blues are easterly anomalies. The reds are westerly anomalies. Kelvin wave generation area, pretty much between these two tick marks right here. This is the date line. So we'll say just about from here to here, but just draw right down the chart. You can see here in September, we started with this inactive phase of the MJO, strong easterly anomalies, and we're going the whole way through September into October now. Easterly anomalies still in play, and that's what we're seeing on the other chart, so this is completely believable. There's some hint that maybe some of this will weaken come about a week out, October 9th, but we're not sure that that's even necessarily the case. Notice all the westerly anomalies are in the Indian Ocean. This would be typical of La Nina, this sort of pattern with easterly anomalies prevailing in the Kelvin wave generation area in the Pacific, westerly anomalies in the Pacific. That is classic La Nina. Looking at some other models, outgoing long wave radiation. So this is really, assume you're beaming a radar down off the ocean surface, bouncing it off. If you have more cloud cover, that would show up as blues, suggesting the active phase of the MJO, suggesting low pressure, more rain, and the inactive phase here south of India, less sunlight, more sunlight reflectivity, meaning less clouds and high pressure. But we saw from the previous charts that really the inactive phase, the MJO, is here. So this is somewhat suspect, or at least it doesn't correlate well. This is the statistic model. The dynamic model also suggests the same thing. Kelvin wave generation area is right in this area right here, and it's not showing. We'd be expecting to see oranges, yellows in here. We're not seeing any of that. So this is kind of a interesting mix and not really indicative of what we believe is going on down at the surface. Phase diagram charts here, also looking for the presence of the active phase of the MJO. The big dot is the active phase of the MJO. Assume, the way you read the chart, assume you're looking down on the North Pole, and the MJO, the active phase, moves from the Indian Ocean, over the Maritime Continent, over the dateline, West Pacific, across or south of the U.S., into the Atlantic Ocean, across northern Africa, back to the Indian Ocean. Right now, the active phase of the MJO supposedly is about on the dateline. We find that hard to believe. The closer to this circle you are, the weaker it is. If the dot was way out here, it'd be exceedingly strong. So supposedly the active phase is there, but we clearly see easterly anomalies in this area too. So kind of a mixed bag here. Anyway, the forecast is the green line here, suggesting the active phase is to collapse in about 2 days and just be incoherent completely. Same deal from the GEFS model here, saying the same basic thing. Maybe the active phase 2 weeks out, trying to show up somewhere, maybe north of Hawaii or south of Hawaii or something like that, but that doesn't even seem very realistic at all. And here's our favorite MJO model, the CFS model. Up about 850 millibars, that's about 4,000 feet up in the air, which is still a good proxy for what's going on down at the surface. Now, this maybe explains a little bit better what's going on. It's suggesting the active phase of the MJO is present. Kelvin wave generation area runs pretty much right in this area right here. This is, again, same style chart, the whole planet on one chart, but past history is here, moving to the future. And you see the blues are easterly anomalies. Yep, that's in play. So and there's easterly anomalies in the Kelvin wave generation area, even during the active phase of the MJO. Now, granted, this is a very weak active phase of the MJO, so maybe that does make some sense. Westerly anomalies all off in the Indian Ocean. Anyway, then you come in by, about the 18th of October. So the inactive phase of the MJO is supposed to show up. And you know what? There's not a whole lot difference when you're looking for blues and yellows here. Just basically a neutral pattern here in the Kelvin wave generation area, that box like right in there sort of thing. And then finally, come November, supposedly another active phase of the Madden-Julian oscillation shows up. And supposedly westerly anomalies are to develop over the greater West Pacific. But we don't believe any of that. This has been on the charts for months now, and it always sits here. It's always a month and a half off, and it just never comes. So we don't believe this. The most likely prognosis is kind of this neutral wind pattern, or maybe slightly biased easterly anomalies, just because we're in La Nina. To have any expectation of real westerly anomalies, especially, that's what you get. You get a lot of westerly anomalies during an El Nino year, but we had that for 2 years. Now we're paying the price. The La Nina pattern sets up, but it's not completely just raging easterly anomalies like what you'd expect. Instead, we just have this very weak easterly anomaly pattern that's actually a good sign and a bit of a gift. We've said this before. La Nina not looking particularly strong. So we've talked some about the atmosphere, but we also need to look and see what's going on in the ocean. West Pacific here, East Pacific here. We're looking at subsurface temperatures. This gives you sort of a hint of what's to come or what's in play. It's the interaction of the ocean and the atmosphere that really help determine our surf potential and storm potential long term. Right now we're in a clear La Nina pattern, a lot of warm water build up in the West Pacific, cooler water in the East Pacific. This thermocline, this shows you where the balance of the warm water is, all in the west. Very shallow, warm surface waters here in the East Pacific. Differences in normal for this time of year, same chart, but only the differences. You see, again, warm water, nothing exceptional, a degree above normal here, a little bit off Ecuador, but basically neutral. But is this flow of cooler waters subsurface down around 150 meters, was that about 3 degrees below normal? Here south of Hawaii, that's about 150, so right there, right in the Hawaiian range. This is pretty much typical of La Nina. If anything, we would expect to see a stronger cold water pattern in this area. If it was El Nino, you'd see warm water falling at depth going through here. Certainly there's none of that. So, and that was what would be called a Kelvin wave. None of that going on. So a weak La Nina pattern appears evident from looking at this data. Another version of that chart using different starting data suggests the actual cool flow is perhaps a bit stronger than suggested in the other chart, but still little bits of warm water here off of Ecuador and certainly in the West Pacific. And yet another way to gauge what's going on here in the subsurface wise is sea level anomalies, differences in height from normal for this time of year. This is strip all the waves out, strip the tides out, any wind chop, any other sorts of effects, and just is the height of the ocean higher or lower than normal? If it's lower, then that suggests cool water at depth, and we're really interested in just the equator region right in here. And clearly we see kind of a neutral, just slightly below normal here off of Ecuador and Peru, but most of the negative anomalies here, 10-degree centimeter differences, are south of Hawaii. There's Hawaii right there. So this is pretty much what, a satellite view of what's going on, suggesting cool water at depth here, but not markedly cold, just a bit cooler. Cold water contracts and sort of helps create that dip in the ocean height that is suggested here by the negative numbers. And yet another way to look at this, West Pacific here, East Pacific here, upper ocean heat anomalies, that is temperatures in the upper 300 meters of the ocean surface. We're going back last year, Kelvin wave number 5, Kelvin wave number 6, warmer than normal water, cooler water all in the far West Pacific. And then you see come March, April, May, the onset of La Nina, all that cool water working its way to the east. We've seen that clearly in the charts. Now notice there's the big push here into about mid-July or so. And then things really backed off this little pocket south of Hawaii. And yeah, it's still there, but things just pretty anemic. I mean, that color there is just about neutral, and that's kind of what's going on. Cooler water, over the central Pacific. We talk about a westward displaced La Nina. If this was a real La Nina, you'd expect to see a lot of cool water, much markedly colder over in this region here. We're seeing none of that. All the warming is here south of Hawaii. I mean, cooling is south of here, south of Hawaii, suggesting a weak La Nina. So you could call it a Modoki La Nina if you're into it, which is a La Nina, but not really. There's also Modoki El Ninos, but this is sort of a La Nina, the La Nina, the cool flavor of that. So then we take a look at actual surface temperatures. This is not the temperatures, but the differences in normal. That really kind of shows you what the trends are. Now, if this was La Nina, you'd expect to see a lot of cold water here off of Peru. We're not seeing any of that. In fact, we're seeing warmer than normal water here, just right along the coast, a thin little cool zone, but nothing significant. Much warmer than normal water out to almost 120 west, both north and south. Now we do have this bit of a pocket here by the Galapagos, and this has been here. It sort of travels along the equator and then really starts blooming once you get west of 120. This is suggested here again of that westward displaced La Nina pattern with a very weak signature here where one would expect it to be the strongest if this was a real raging La Nina. Here's the trend for the past 7 days. Now again, along Peru, neutral temperatures, a little bit of cooling. These blues are pockets of cooling just in the past 7 days. So things are cooling a little bit between the Galapagos out to 120 and warming a bit out, where the main cool pool is, but nothing too significant. And here is actual temperatures. So here is the main cool, or not actual temperature, sorry, anomalies, differences in normal for this time of year. But the main pocket of cooling is way out here, again, south of Hawaii. And now last week, this was all yellow and orange in here. We're seeing a couple of small pockets starting to show up. So that equates pretty well with when we saw these pockets right here. Yes, we're starting to get a little bit of cooling. But again, along Peru, where you'd really expect to see the bulk of the cooling up in here, not a whole lot going on. Over Africa, early signs sometimes of what's going on, much warmer than normal temperatures here, suggestive of no major push of, we don't expect La Nina to all of a sudden balloon up and just start really turning on anytime too soon. So let's sort of go back and just sort of get level set here. We've been talking about the MJO, the Madden-Julian Oscillation, and that helps sort of create or fuel the storm track short term in 3 to 4 week intervals, or suppress it, right? 3 to 4 weeks in the active phase over the Pacific, which would support storm formation. 3 to 4 weeks in the inactive phase, which would sort of dampen storm formation. Then we've talked about El Nino and La Nina. Those are more like 5-7 year sort of trends. We're coming out of El Nino, so one would expect a suppressed storm state for the balance of this year, just on the general sense that La Nina is in control of the Pacific and, for that matter, global weather. But what we're also seeing is the La Nina is very weak and westward displaced. That actually opens the door a little bit to suggest that maybe this winter will not be a wash and that we could actually have some decent storms. It's not going to completely suppress storm production like it would if it was a strong La Nina. Also now, we can look at here the Southern Oscillation Index, difference in pressure between Darwin, Australia and Tahiti here. Positive numbers suggest the inactive phase of the MJO, and you can see here for the past 30 days it's all been positive and fairly strong here in mid-September, and a little pocket there even in later September. The current value +7. Negative numbers is what you want to see here if you're in the active phase, the MJO. The 30-day running average here, you can look at the trend from 6 on September 30th, and it's steadily building, suggesting the inactive phase, the MJO. Looks like it's about peaked out right now, 13.82. Then the 90-day running average gives you a sense of whether you're in El Nino or La Nina. If it was negative numbers here, you'd say El Nino. Clearly it's not. We're rising up to 7.93, and we started at 4.54 a month ago. So suggestive of La Nina, not particularly strong, but certainly present just the same. Now, the ESPI index, that's what we're looking at here, pretty much the same sort of thing. It measures the total amount of precipitation, satellite-based precipitation north of Darwin, Australia, and then north of Tahiti here. Positive numbers in this index suggest El Nino. Negative numbers, La Nina. The current value, minus 1.6. This is the lowest it has been so far this year, suggesting that La Nina is still gaining some steam. And you can see not a whole lot of precipitation. This is the anomalies for the last 30 days. Not a whole lot of precipitation in this area. Most of the precipitation here in the Indian Ocean, pretty much as one would expect. Going back real quick, again, back to the Southern Oscillation Index, you can see the 30-day average. That sort of takes some of the noise out of it. You can actually see the pulses of the Madden-Julian oscillation going from active when it goes negative to inactive when it goes upward spikes, downward spikes. So this is the El Nino push here from 2014 through October or so of 2015, and then maxing out somewhere down around in here. And then now you see the positive trend upward push towards La Nina. Still not particularly strong. 30-day average was at about 14 or so. Oh, there we go, 13.4. Okay. But still, La Nina has gained a little over the past 3 weeks or so, 2 to 3 weeks. And we're seeing that in some of the other values. So we're not seeing it in the ocean temperatures so much, just more in the atmosphere. And then finally, the forecast for the Nino 3.4 region. Here we go. This was back January 2016, peak of our El Nino. Positive temperatures in the nearly 3-degree range. In the Nino 3.4 region, that's pretty... from 120 west out to about 170 west, that's where they monitor El Nino, the main ocean temperatures there. We see temperatures falling, of course, as we transition to La Nina. But the transition is not like a giant correction down into -2, -2.5 degree temperatures, which is what one would expect given the strength of this El Nino back earlier this year. Instead, we're down to half a degree below normal and have been sitting there. The forecast has us inching our way down to about almost 1 degree. This is a little bit stronger than what was forecast a couple of weeks ago, a little bit more in the negative range, but still only lasting for a month or two, and then start tracking back into neutral territory come April. If this is the price we have to pay for the previous 2 years El Nino, that's not a bad price to pay at all. Recall, after the 97-98 El Nino, which was a very large one, we went into a very deep, dark hole of cold water for multiple years. We're not seeing any of that this year. In fact, after the 98 El Nino, now we talk about yet one more oscillation, the Pacific Decadal Oscillation, that runs anywhere from 15 to 25 years, and it runs in cycles that either support La Nina or support El Nino. The thought is, because these forecasts look so weak, because all the data we've looked at related to not only the MJO, but really El Nino and, well, La Nina here looks like a very weak La Nina. This suggests to us that perhaps the Pacific Decadal Oscillation is finally changing. It's been negative since about March or April of 98. We think we might be finally digging ourselves out of that hole 18 years later and starting to move towards the warm phase of the Pacific Decadal Oscillation. If that is true, then perhaps for the next 20 to 25 years, we could be in an environment that favors El Nino. That means this is our big price to pay right here for a year or two, then not a big price to pay at all. And then the picture becomes much more active for storm development, not only in winter months, but also in the summer months as well. So that's the thought. But again, you don't really know whether you're in what state, or, if you're changing states for the PDO, it takes 4 to 5 years before you really know you're there. And we're only 6 months into it. I've said in the past, maybe next year, sometime in the spring or June-ish time frame, we'll know. We'll have a much better sense of where we're at, but already we're seeing some signs that suggest maybe, in fact, we are changing from the cool phase of the PDO to the warm phase, but we need a lot more evidence before one can make that call. It's not a binary switch. It's a trend, a long-term trend that not a lot is known about, but we do know that it exists, but the science behind it is very inexact at this early point in time. So to quickly wrap things up, Southern Hemi looks like it's asleep. North Pacific scheduled to come online with 2 decent gales forecast over the coming week. Possible swell resulting, and the models are looking pretty good right now, but hard to believe, especially when you're looking 5, 6, 7 days out. But the trend looks good regarding that. MJO-wise, still in the inactive phase of the MJO. Despite that, storms are forecast to form. Not unprecedented, just not as likely as one would hope for. And then, of course, the whole PDO thing. Yes, maybe we're getting there, maybe we're not. We'll talk more about it over the next 9 months. So that's it for now. Looks like we're moving into fall. Finally, go get some surf when you can. Be safe. We'll do this again next week. Same time, same channel.